be fast with this. So can you see my screen?
Yes,
Okay.
we can see your screen.
Okay, so basically what we are talking about since was that what is a database, and we said it's an organized collection of data, and we use baskets to make an example that you can store orange in a basket, you can store fruits in a basket, right? And then you can also retrieve those fruits from it. The same way a database can store data and then can be retrieved, the data can be retrieved from it electronically. And the way to interact with our database in most cases is through a database management system. And there are several types of database like the SQL, the Postgres SQL, the SQLite, and so on and so forth. The MS SQL, okay, yeah, it's still called SQL or MS SQL. That's the Microsoft SQL. So we make an example here. We describe this, right? Uh, we had a look at this where we said, why is the who is speaking? You said what? So a database can basically can be stored in a server. A database can is supposed it will be on a server, and then the server will host both the database and the database management system. So with the database management system, we can create several databases, right? Can create several databases, and then on these databases, we can have series of tables or several tables that are connected. And then we talked about how we can use SQL to manipulate it, to create database, to drop database, to create tables in databases. And then this SQL, we said it can be the one that a developer or an analyst works with directly, use the SQL to manipulate the database through the database management system, or it can be done via an application. For instance, when you are creating an account on a platform like Facebook, Twitter, and so on and so forth. And then we also said that database can be managed through a business intelligence platform, right? So that's basically all for that. And then we came here to look at creating uh, what tables and columns are. So, and I was given an example that just like on your what's it called, on Excel, what you have here is a simple table, right? It's a simple table. So this table is formed from is from this customer uh is from this customer, I think customer table. That's where we forge it from. It's an entity. You will understand what an entity is shortly. So looking at this customer, we can use it to create a table. So this is the table, and they have their data type. The primary key, which is the integer, which is an integer in this case. We have the first name, the last name, email, phone number, and these ones, they are varchar. That's variable characters, right? So meaning that they can vary in length. That's basically what it means. So you can have a table here, and then let's say the first one, customer ID is one. The second one is the first name. We can say the first name is Joe, and then the last name is also Joe, and then the email is Joe at Gmail. If you are thinking Joe at joe.com, repent. So Joe at gmail.com. And then we'll have the phone number 08136 and so on. So basically, you can have this information stored. Now, all these ones are variable characters, right? They can be a combination of characters, starting from alphabet to special characters like this @ sign you are seeing here. I'm going to click on it as a link. It's coming up. So I believe you can still hear me, right? Can you hear?
Yes, sir.
Okay.
Yes, we can.
Okay, so we can store these
We can
informations
hear
like
you, sir.
this. Okay, thank you. So we can store these informations this way. And yeah, this is for a particular customer. And So this record you are seeing can be entered by using SQL, can be entered by by an analyst or a developer, can be entered through an app, can be entered through a business intelligence. But all of them will be entered into this table using SQL as a language. All right. So um, so basically that's what we have here. Then we go into types of database. So database varies, right? They have different types. We have the relational database, which organizes data into tables and rows, like the one you are looking at just now, the example we gave. That's for relational database. We have database that okay, for example, the example of relational database is MySQL, is PostgreSQL, and I was showing you that this is my PostgreSQL. On this POSI database, POSI, there are three of them. There's POSI, there's Postgres, there's warehouse staging. But I'm going to show you this POSI. So under this POSI, you go there and then you can look for under the schema, you should see tables. These tables down here. I just want to show you where tables are stored. You should see tables. You can see under tables, we have several tables. We have accounts, we have order, we have region, sales rep, web events. If you are part of those people who have been mentoring privately for over 3 weeks now or so, you would have been familiar with the sales rep. I think I shared a data with them called sales rep. So it's the same thing with what you have here. So if you click on one of these tables, you see columns. You can click on the columns and then you see all the columns in that table, right? This is all the column under the account table. So you can query this table if you want to. Let me see. Okay. Let me just query one of the tables. Mm. You can also count rows if you want to, but let's just query one of the table and see. You should generate this thing by default. Why is it not generating it? Oh, now this is not a good method, but let's just assume that we all understood what's going on. Okay. So in the future, you will be the one to even tell me, don't do that, it's bad. So let me see. Yeah, you can see it here. This is the result. So on the table, remember on this table, this account table will have ID. This is the ID on this first one. We have name, we have website, we have latitude, longitude, primary, POC, sales rep ID, and so on and so forth. Okay, this is just to give us an idea what tables, columns, what they are. So in a database, you have several tables, and on the table, you have several columns, and then you can query them. Are we good? Are we good? Do you get this? Um,
I have a question, sir.
oh, okay. Please go ahead.
Yeah, what's the bad thing you did? You said you did something that was bad.
Oh, okay. Yeah. Whenever you are querying a database, don't go with asterisk. What this asterisk is saying is that
Oh, okay.
query
Okay,
all the
selecting all.
yeah, it's saying query all the columns. You should not query all the columns because
Okay.
it's not cost efficient, especially when you're working on cloud. Like you're working with BigQuery, you're working with Redshift. If you're querying all the column, AWS or Google Cloud, they will charge you for all the columns that you are querying. And most times you don't need all the columns. So you're supposed to actually pick the columns that you want. Like in this case, if all I want is just the ID, the name, and website. I think there's a change here. I think there's a change here. It should throw me an error. Okay, no error. Because it's kind of vary. I think it's because of the way I load this environment. There's a way I can load it. I have to reference the what's it called? The table, right? I have to use the table to pick the column name. Right. What I mean by that is that you now have to do accounts. account dot the column. Then you do that for each. Think, sorry. Don't worry, you get this. Don't feel stranded, don't feel confused. So you have to do this, right? In some cases, but because of the way I load this environment that's here, I went to this table and then I load it. So I wanted to query that table. So I don't need to put all those things, all this account. I think just like this is fine. It will run. So you see, that's why you're having this. So it's good that you always work with the columns that you need. Don't put asterisks. Asterisks will load all the columns. This is just one method of optimizing. There are other methods. So we have the key value. The key value, they are dictionaries. They are dictionaries, right? They have the key and then there is the
So please,
value.
I wanted to ask a question.
Okay.
So please, why is the website showing like blue color, then the ID and other things are showing a different color?
Yeah. By default, there's what they call keyword, right? Keywords are the reserve word in the particular language, be it any programming language. So here it is sensitive that select is a keyword that we should be
Hello,
using.
sir.
Aha, have you lost me or I'm the one that lost you? Can you hear me? Hello? Hello?
Hello, we can hear you.
Oh,
We
okay.
hear you. Well, I'm
Okay.
hearing you.
I mean,
Okay. Thank you. So it's a reserve keyword. So there are some reserve keyword here, right?
yes, I can hear you now.
Okay, there are some reserve keyword. That's why you are seeing them in this color. Like this is supposed to be a variable, and this is a variable. That's why it's not I don't know what this color is. I don't know whether it's purple or pink. I don't know what it is, but it's just signifying that they are reserve keyword. However, since our table also have a similar name, it will not stop it, a similar name as the word, it will not stop it it will not stop the code from running, right? But this is not ideal way of naming columns. This is just a sample data, right? So it should not be picking the name
Okay.
of keyword. These ones are because they are picking a keyword name. That's why it's picking that color. For instance, reserve keyword,
Okay.
select is a reserve keyword, from is a reserve keyword, right? So
Mhm.
we are using them. Anywhere you type select is select, from is from. It doesn't change. But when you now name your
Okay.
column select, you now name your column from, you see, it kind of causes some kind of I think it is called ambiguity or something. It causes confusion. But Postgres is still able to identify, like to separate them to know that here we are not referring to keyword, that we are referring to column names. Okay.
Okay, sir. Yes, sir.
So you're welcome. We have the key value. This one, a clear example is Redis, DynamoDB. I don't know if some of you have heard of MongoDB. Mongo also store key values. I have Mongo, but I'll have to log into I have one of those key value database online, not here, not locally on my computer. I'll have to log in to show you, but I'm very scared and worried because I don't want to log in now and then by the time I'm done logging to Mongo, I've logged out of Zoom. So let's continue gently. Maybe some other time I'll show us. But basically what it means, let me show you an example, how it stores information. How it stores information is this. It stores them in this format. You see, there is a coily bracket. Is that a coily bracket? Well, how did they call this? This is not braces. This should be a coily bracket. Then you can have name, and then the name is Joseph. Then you put a comma. Then you can have phone, and then the name is the phone number is 0913333. So you put a comma and so on and so forth. So this is how it stores information. It stores record. right? So this can be referred to as a record. Then inside the record, you have items. This is an items. This is another item here. Now for this item, the first side here is called the key. The second one here is called value. Okay. The one by the right is value, and then the one by the left is key. I don't know if you get me. Then inside it, you can also have a nested record. You can have another record inside the record, right? And then in this case, you can have let's say um let's say address, Lagos. You can have paid. You can call this is paid. And then you can have it to be true or false. It depends. And then so on and so forth. So basically, don't forget, we have the key and then we have the value. So every time we want to pick a particular value, we need to use the key to get the value. Okay. So, but don't bother yourself about that. But you get familiar with it when I'm taking you guys on Python programming language. But for now, don't stress yourself. We don't need to go too deep into it. Just know that the one by the left is the key, and then the one by the right is the value. So this is how the record is stored in a what's it called, key value database. Okay. So we also have uh document document database. It's just an improvement on the key value. Nothing special about it, right? It's an improvement on the key value. So this time around, you have a bunch. Key value kind of like deal with a very light quantity of data, right? So basically, it's used sometimes as a catch. When I say catch, sometimes you see your phone, you are watching a video on YouTube, and then you've gone offline. The video is still playing. It has been stored on a temporary memory. That's why it's still playing, right? So it can also happen to even key value documents. It can be stored temporarily somewhere, especially when speed is very important. So they can be stored as a cache in a temporary memory like Redis, like DynamoDB. But an improvement of it, where you now want to store them permanently, that's where MongoDB comes in, CouchDB comes in. So in this case, you now have them. I think I would have shown you guys, but I don't know if Mongo will allow me to do that. I don't know if Mongo will allow me to do that. The record I wanted to show you now, I hope I don't go offline. Can you still see my screen?
Yes.
Okay. Let's see.
Yes.
I hope they allow me to log in. Oh. If you're hoping to see my password, nothing for you. They are going to be talking about verification. Let me just go here. Let me go there and copy this verification code. Trust me, nothing can happen. Even if you like, which one did I click on just now? Yeah, it's this one. So we'll put this. Aha. So I cannot be reached. It shall be reached too. Okay, it's loading. Remind me later. I'll have to change it because I'm actually recording this video so that somebody will not go and try to attempt to hack into this account. It's holding some very vital information, which I'm going to show you now. So I'm building a platform. This is an opportunity to share it with you guys. I'm building a platform called Spirit and Life. That platform pulls all form of data, like audio data, video data, pull their information, their URL, store them on Mongo, and then I have this web interface where you can go, you can search for any messages you're looking for, any songs of Pastor Nat or Minister Dunsin, or messages. You can stream those messages on the application. You can download the audio. You can also stream the audio right there. So this is the database I'm showing you. This is actually supposed to be, you see, there's audio record, live update. This is one I need to work on next so that you can watch live session on the app. So here is the YouTube record. This one is updating. Here is, I want to show you an example of what's it called? Example of document. Yeah, document DB. So just be patient. I don't know why it's slow. Be patient, be patient. I guess it's still loading. Yeah, it's still loading. So fetching documents is going to show us now. I hope you guys can see this.
Yes.
Okay. So don't bother yourself about this platform. Don't bother yourself about all the English I'm speaking. All you just have to know is the feed and value, or the key value, what is stored here as document, just for you to have an idea of how Mongo is. Other ones, I will not be able to show you anything on it. So just move on so that we can save time. It's fetching, I mean, there's a lot of record here. We have over 20,000 record, and it's updating itself, I think, every 12 hours. I have a pipeline that updates this particular collection every 12 hours. And the same thing for the audio, similar thing I will do for the live update. So, yeah, just be patient. Just be patient, it's loading. So while it's loading, let's go back and look at something else. So we also have the graph. An example, what the graph basically does is that it has nodes and edge. It is used to track relationship. When you have, for those of us on social media, I'm not on social media except WhatsApp. For those of you on social media, when sorry everyone, I remember I said that it's not a good idea to go and let me just stop it because I'm managing this network. Or can you hear me?
Yes.
Okay.
We
We
can.
can hear you.
So I've stopped the operation because it needs some bandwidth to load the data. So back here, so we have the graph, we have the wide column. So this one basically uses column families to store data. So basically what this one is saying is when you're talking about this, what they call one big table. One big table is that the table has not been broken into smaller chunks. So you just have one entire big table, maybe with 200 columns. So you store it on such information or such data can be stored on Cassandra or HBase. They are also called wide column database. So we're going to talk about database design. We've talked about type of database. There are those we didn't touch here. These are like we didn't talk about data warehouse. We'll look at it shortly, maybe later on. Yeah, I'm back. So I couldn't take excuse. I had to take. Network is really terrible this evening. I'm so sorry. I'm so sorry. Can you hear me?
Yes, sir.
Yes, I can hear you.
Okay. So let's just continue. So we are talking about database design. Where is it? Okay, not you. So we're talking about database design. Yeah. So we have there are basically two types or fundamentally two types of database design. We have the logical schema and the conceptual ER diagram. So the conceptual ER diagram just basically needs to show us how the entities are connected, the relationship between them, the attributes, and so on and so forth. For example, what you have here on the right is showing us an entity which is song. This for an for instance, you have an artist. The artist should have a song. The artist most likely will have an album, right? So let me use this to show us. So we have an artist. We have an artist. An artist is an entity. The artist can create another entity called album, and the artist can also the album should have song. Hi everyone. Apologies. I'm so sorry. Network is terrible this evening. So bad.
Yeah.
Yeah, they know they know we are Nigerians. Anybody that is not from Nigeria automatically know that this is us. Our network, just like our electricity, is always dancing awilo. So now, let me see. I hope it will not stop me from sharing again. So I was talking about conceptual ER diagram. So there is what is called an entity, and for every entity there must be a relationship, and the relationship is to the attribute. So we start with an artist. An artist is an entity, right? So this artist must have attributes. Attribute like label, like artist ID, like genre. These are attributes. There is no way you say an album. Album does not need a label. It's artists that need a label, not an album. Okay, so there are key attributes tied to this. For instance, you have a farmer. What if a farmer is an entity? What are the attributes of the farmer? You expect the farmer to own a farmland. You expect the farmer to have hoes. You expect the farmer to have cutlass. All these are attributes of the farmer. Okay, so the next thing, the artist, which is an entity, can also create an entity. An entity can create an entity. In this case, you have an album. An artist can own an album, and then this album has its attributes. The relationship of the album to the artist is that the artist created the album, so the album belongs to the artist. So the album has attributes like the album title, the number of song in the album on the album ID, because you can have multiple albums, right? So you need to have album ID, just like the way you have artist ID, because you can have multiple artists. Then this album must have songs. So song in this case is also another entity, and then the songs, they must have titles, they must have length, and then there must be song ID, because you can have multiple songs. This is just a conceptual way of following it up, but you will understand it better when you start looking at the logical schema. For those guys for the brothers and sisters I've been mentoring, they are already somehow, to some extent, getting familiar with the logical schema. That is, it's an ER diagram. Though they may not they may not understand this ER diagram, but they already know how to translate it. I will show you what I mean by that. So, let me go here. Yeah, this is another example, right? In this example, this is the same thing as the first one, as this conceptual. This is conceptual, but then it can be translated into logical. Right? In this logical, what you have is that you can have three, just like in the conceptual, but now we are no longer looking at the entities, they are tables. So we are no longer looking at them as entities now. We're looking at them as tables under the logical schema. That is the logical approach to database design. So you have songs. The songs have song ID. The song table have song ID, title, length, album ID. Then you have the album here, and then you have the artist. There are three different tables, right? So for this, they are related, they have a relationship, and the relationship between the song, between the artist and the album is via the artist ID. Let me, oh no, yeah. So you can see that the relationship between these two tables is here. You have the artist ID here, and then you have the artist ID here, right? So it's what connects the albums and the artist. And we'll talk about primary key and all that later, foreign key, but don't worry yourself on that now. Then the song and the album also have a relationship, and they are connected by the album ID, which is here. So you can see that they have a common column that connects them, that helps them to relate. So basically, that's for the logical schema. It's just how the tables are connected, right? How the columns in the tables are defined, and then how the tables are connected. So remember, entities becomes table. So if we move further, come here. So this is another example I want us to look at. In this example, we have employee, we have department, we have project. So employee has a relationship with the project. So the relationship is connected by the project ID. We have a project ID here. This is a common column, okay? A common column between employee table and project table is the project ID. Then there's also a relationship between employee and the department that the employee belongs to. And that relationship is established by the department ID, which you're also seeing here, department ID. So with that, you can connect the two tables. You can merge them together. Yeah, that's still under logical schema, just to give us an idea. So the next thing we'll be looking at, if we are okay, is in-depth look of the types of logical schema we have. We have the star schema, we have this snowflake. So what this is saying, first we have to understand what dimensions are. In a database, when you have several tables, those tables are referred to as dimensions, okay? So, and then these dimensions, they are of different type. We have the fact dimension, and then we have the, what's it called? Okay, we have the fact table, then we have the dimension table. I think that's what I meant to say. I hope you people can hear me. Okay, I thought I have a message.
Yes, sir.
Isabella, this one you're laughing. I don't know why you're laughing on the chat, but maybe you're happy that Valentine is coming. So we have
Oh,
them.
sir, it was when you about the
You said when I did what?
when you were talking about the network issues, that was when I was
Oh, okay.
laughing.
You're laughing now because you're a Nigerian. You're not a Portuguese or Brazilian. So that's why you're laughing. So we have the fact table. The one at the center is always referred to as the fact table. This fact, basically what it holds is the metrics and the entire foreign keys. Now we have to start talking about what private key is and what foreign key is. And that will take us to, let's quickly take a look. We are still going to look at it later on this slide, but let's quickly take a look at this example. This is an exercise done by uh, this person, by Julie. So what you see here, um, so what you see here is basically telling you this is a primary key. So this customer ID is called a primary key. Why? Because it exists primarily under the customer table, right? Now, if you now find the same customer ID column in another table, it becomes a foreign key. That's why you are seeing FK here. It becomes a foreign key. Why are you finding it in another table, like the others table? Because that's the only way to connect the others table to the customer's table. So every customer must place an order, and the order will be registered under the order table. Then the customers, anytime you want to, do some analysis of how customers, make orders, you now have to connect them using something, using a key. And the key in this case is the customer ID, but it exists primarily on the customer table. Then it now should re-exist under the orders table as a secondary or a foreign key. Let's not call it secondary, it's foreign, right? So we are still going to talk more about what they are types of keys and how they can be of help. Okay. Another one I think I can use as an example is also this one she did here. Here you have something in common. Yeah, order item table and then orders, right? So the item that we are order and then the order itself. So all this, they have their description. And if you want to connect them now, the order item has a column called order ID. And this order ID, with it, you can join to this order table because there's also an order ID here. Though in this place, I think she left it open. She left it open. But then anyone can be a primary key and then the other one will be a secondary, will be a foreign key. So in essence, what are we talking about when we are mentioning key? Key helps us to join two or more tables together. That's basically what they help us to do. But then they have rules that guide them so that we don't have duplicate keys. We don't have issues, joining two or more tables together. Okay. So back to our dimension table and fact table. The fact is always at the center. The reason they call it star schema, the fact is always at the center. And then the other dimensions, they are the extended arm, right? When I say extended arm, I mean immediate extended arm. You will not find any other extension beyond this one. They are all connected to the fact, which is at the center here. This is the fact. So what this fact contains now is that you are now seeing sales ID, book ID, time ID, store ID. All these are foreign keys, except the sales ID that is primary key. So you have metrics here like sales amount, quantity. These ones can be here because they can change, right? They can change. This column information can be here because they can change. But the ones that won't change, for instance, the time dimension table, this one day can change, month can change, quarter can change, year can change. So they have their table. And then with time ID, you can connect to it. All this one sounds like I'm speaking too many English, but don't worry, when we start the hands-on session, you will understand better. So basically just understand that we have the star schema, and for the star schema, there's always a fact table at the center, and then other side of it, we have the dimensions. Okay. Can you hear me? Hello.
Yes, sir.
Yes, we can.
Okay.
Yes, sir.
Do you understand? It's one thing that you can hear me, it's another thing if you understand. Do you understand?
So
No,
far,
sir.
so good. Huh?
Yeah. So you said?
I said so far, so good for me.
Okay.
No, sir, I don't understand. I don't know. My network has been kicking me out. I just joined, so I'm just trying to understand what you've been saying.
Who else is having issue understanding?
Me
Sam
too, sir.
me.
Ah,
I don't understand, sir.
this is a family issue.
Me too. I just joined. The network also
Hey,
was
Bree, swallow
kicking
it.
me out, so I
If you
just
do
joined.
me too, you'll be in trouble. Swallow it. So, uh, okay, I'm joking there. But then, okay, let me just quickly explain it one more time. But you will understand better by next week when we start working on these things. You will see what we're talking about. So when you're talking about a star schema is a type of logical schema, right? And for a star schema, is just one dimension. What they mean by one dimension is that you have this facts table at the center, and then you have the only thing you have is the dimension tables, just one dimension table extended from the star schema, one dimension table at each side. Nothing else, nothing more. They are joined. Those tables can be joined by the key. Okay? They can be joined by the keys. So, but I'm going to show you the other one so that we'll now come back to that one for you to understand. So we'll now have the snowflake schema where we have more than one dimension. So in this case, remember earlier we have the fact, right? We have the fact table, and then we have one dimension, and then one dimension. But what Snowflake is now saying is that that dimension can be further extended. You can have another extension of it here, another dimension of it here. So basically what it's saying is that you can break the table down into a way smaller, what's it called? Tables. You can break them down into smaller tables. And what this is all about is normalization. You are normalizing the table. That's what you are doing. So when you say you're normalizing the table, instead of having one big table, you are breaking the table down into smaller chunks. And we are going to see the reason why we do that. Okay. So now when we come back here, you should now, I believe you should now understand what this one is all about. What this star schema is. You only have one dimension everywhere around the fact table, right? But when you come to Snowflake, you can have it extended. You can have more than one dimension. All right. So are we good? Because I'm eating your time.
Yes,
Yes,
sir.
sir.
Okay, I will advise you rewatch it. Okay. So just give me, let me pause this screen sharing. Just give me a second. Okay. Yeah, thank you. So that is what normalization is all about, breaking a big table into smaller tables, right? So we are going to look at what that now the uniqueness of each of those tables. Sorry. Yeah. Hello everyone. So as we are talking, now we are going to look at what makes them unique. The fact table holds records of metric. So basically what this is saying is that what you're going to find there is like, for example, what you see here, you see sales amount, quantity, those are the metrics that is referring to. Then we have it changes regularly. Yeah, sales amount can change, right? Quantity can change. And it can connect to dimensions via foreign key. You can see that on this, we have sales ID, book ID, time ID, store ID. All these are, except the sales ID, all the other ones are foreign keys. The sales ID is the only primary key here. So it can connect to the other tables using this foreign key. Those are the features of a fact dimension or a fact table. Then we have the dimension table whose description of attribute does not change as often. Description of attribute, right? On what this simply means is that when you're talking about the store, store has address, store belongs to a city, store belongs to a state, store belongs to a country. So these are like fixed information. They don't change often. Then if you're also looking at book, book has title, it has author, it has publisher, has genre. This doesn't change often, right? So they are fixed. That's for dimension tables. And yeah, that's basically it for the difference between fact table and dimension table in a star schema. So remember, star schema has one dimension. Snowflake has multiple dimension, right? And we are going to quickly look at this. So what is normalization? What you saw on the Snowflake is an example of normalization. So normalization is a database technique, right? You split a table into smaller tables and connect them via relationship. That's what normalization is all about. So, and when we do that, it helps us with two things. First, it helps us to reduce data redundancy. And second, it helps us to increase data integrity. So you trust the quality of the data you have. That's for the data integrity. And then to reduce redundancy, instead of having duplicates of rows everywhere, or you just find a way to minimize that. Okay, you don't have duplicates of row here and there. So database normalization is very important. Breaking data big table into smaller tables and connecting them via relationship. And don't forget two things: reduce redundancy, increase integrity. So going to database key. This one we are going to be very fast because it's not that difficult. So do we understand up to this point? Anywhere you don't understand, can you note it down so that when I return, when I'm done with database keys, I can explain it again? Okay. Hello.
Yes, sir.
Okay,
Yes,
thank
sir.
you.
Yes, sir.
So tables are related. Every relationship between tables is enabled through keys, database keys. And these database keys, we have basically two types: primary key and foreign key. Okay. Um, so a primary key has a very unique value. So you won't find any duplicates there. You won't find null values there. They are very, very unique. So it belongs to a particular table. Then this same column that we are calling primary key can be replicated in another table. And then if it is replicated in another table, you can now refer to it in that other table as a foreign key. It's no longer primary. Okay. So the uniqueness of keys, of primary keys, is very important because each key is identifying a row. Okay. So what I mean now is that if you look at this Excel, this is customer ID. This is a key. So this one you are seeing here is allocated to this row only. So when you come to the next row, you should be expecting 2, and then the other one 3. So you shouldn't be seeing 1 here. That is wrong. So for primary keys, there must be uniqueness. There's no room for duplicates. Okay. So yeah, we'll come back to this, and then we'll look at foreign keys. Foreign keys is more of like having the same column that you are calling a primary key in another table in a new table. So the table where you now have it now is you now refer it in a new table as foreign key. So what this means, let me show us quickly. What this means is that for instance, we have ID. This is the fact. This is dimension for store, dimension for product. So here, product ID is a foreign key on this fact cell, but it's a primary key here on this dimension product. You understand? So for each of those table, like this table here, the key you see here is primary to this table, but if you find it somewhere else, it's going to be foreign. So you also have a key here for this store ID. So anywhere you find it again, which is here, is going to be what? A foreign key. So why do you find it there? So that we can be able to connect these two tables, right? If you also want to connect these two tables, you also use the keys that is common with them. Okay. So that's that for that one. And then we can also look at other types of keys. There is the surrogate key. Surrogate key simply means that there are times systems generate key by themselves. Your database system can generate the key. So that's basically what surrogate key is talking about. Nothing special about it. So it doesn't have any real world meaning. It's just a key generated by the system. Like for instance, if you have an application, a software application where you can go and register, the moment you register, you didn't create any key, but the system will automatically generate a key for you to identify you as a unique user. So the system generated keys are surrogates. Then there are other ones like composite key. Composite key is not here. I didn't mention it. Composite key is only talking about merging two keys together. Let me give us an example before we move forward. Let me give us an example quickly. Here. Don't worry, you are going to rewatch it and you will understand. So let's say we have customer ID. Okay, and then we have product ID. Or you can have not customer ID and product ID. Yeah, okay. Let's just use this. So if customer ID is A1, A2, A3, and then we have product ID like okay, let's say P1, P2, P3. So we can create a surrogate key here. Sorry, a composite key. What composite key is simply talking about is you can take, I just want to show us an example. This is not the way it will be in the database, but let me just show you an example. You can have this plus, you can decide to join, put an underscore, and then plus again, this one. It can make them that way. And there's a way I used to do this, so it's like I've forgotten. There's a way I used to, bring the two of them together. But let me see. Let me see if this will work. It still will not join them. Okay. I think concatenate can do it. There's a way I used to join concatenate. Come on. So let's concatenate this one and this one. then close it. So you can see. So you now join the two of them together to form a new key. This one is called a composite key. Okay. It's called composite key. You can call it a composite key. So you join two keys together to form a new key. If you are lost, I always like that you take note. If you are taking note, you should be able to answer at least one of these two questions. The first one, Postgres is an open source database administrator. A, false, B, true. Put your answer in the chat section. I hope you people have not gone to bed. The way everywhere is quiet.
We're here, sir.
We're here.
So Julie
Yeah,
says
with you, sir.
true. No, don't be with me. You have to be able to get it. But don't worry, if you watch it the second time, you get it. So those of you that is saying is open source, my number one question to everyone in this call, what do you mean by open source? When they say a software is open source, what do you mean by it's open source? Don't use ChatGPT on me. I'll catch you. What do you mean by open source?
Is it like free, like it's on the net or something?
Okay. Yeah, it's free. It's free for the public to use,
Yeah, to use.
but that free, has some wrapper tied to it. It's not free because when you want to host it, you will still pay money to go and buy infrastructure to host it. Basically, they said it's free because you can, run it locally on your computer. But when you want to run it on the cloud, you have to pay for infrastructures. So there are some that are closed source. Those ones you cannot install it locally on your computer. You have to just go straight to them, pay them, and have access to it. So the second one, conceptual ER and logical database are the only two types of database. Database design. I should put design there. True or false? Hello. Is it that you people were not taking notes? Is it Julian Starris that is here? Where are the rest of you?
They're having relationship with their network.
No,
They are
that's
very
not.
relationship. Who is speaking? Who said that?
La.
La what? Your name is Starris here. I don't know your real name.
Is my phone Stella, sir?
Oh, okay. Stella, you are the one saying people having relationship with their network. That's all you grab from this class. Well done. Okay. All right. So, I think they will have to rewatch it. I really want us. This class shouldn't take us an hour, but now it's about to take us 2 hours. So, the other thing we have to take a look at is the database processing technique, right? So, the question we should be asking is how should we organize and manage data? The first thing we should take into consideration is the schema. How should my data be logically organized? And for those people that have been mentoring of recent, you see that the videos I'm sending you with the task, the first thing I was trying to get you people to be familiar with was how to organize a database. That's why I gave you guys an assignment that you should work on this. Just create a simple table on Excel sheet and show which common column connects them, right? So then the next thing is normalization. Once we have been able to, have an idea of how we want to logically organize the schema, that's the database itself, next thing we should be talking about is normalization. Should my data have minimal dependency and redundancy? Okay. So in this case, you are simply talking about whether that's the dimension, the fact and the dimensions. So the more you try to reduce redundancy, the more you are most likely going to have dimensions, several dimensions. But all this, don't worry, is conceptual, is theoretical. For now, just have this at the back of your mind. You will understand it better when we start doing hands-on. So we have views. What joins will be that is what joins will be done most often. So the essence of having views is that you want to know which tables will be, merged together often. And then once you know which ones will be made together often, you can create a view for it. Okay, so that you don't have to be running the code over and over again. Because if you're working on cloud, as I said earlier, the more you run the code, the more you pay. You pay for every time you run the code, you pay. Unlike the one I have locally here, I don't have to pay. I can run as many times as I want. I think, yeah. So this is your code. The more you run this, every single time you run it, you have to pay. But this is locally on my computer, so I don't have to pay anything. What I'm telling you is that when you're working on cloud, you have to. You really have to. So, because it's on the server, you have to pay for the infrastructure. Then access control, you now want to manage who have access to what and at what level do they have that access. You don't give a complete access to you don't give people admin access or, total access because they can mess with the data. I remember I was working on a project with a guy. The software engineer was like, you know what, Joseph, I want to give you access to our MongoDB. I want to give you full access and admin access. I said, no, I don't want. I want to give you the password and everything. I said, no, I don't want. Just give me access to what I need. So let us know who has access to the entire thing so that when anything goes wrong, we can know who to actually hold responsible and know how to fix it. But if everyone have full access to the database, when issue comes up, we don't know who went to mess something up and we don't know how to fix it because before you fix some problem, you need to know how the problem was created first. So, and the next thing is that how do we pick between SQL and no SQL option? Now, I know I did not mention this to you guys earlier. We have SQL, we have no SQL. No SQL is simply talking about document DB, the one I showed you guys on Mongo, right? It's simply talking about this. Mongo is an example. So you can use SQL on that place. You can use SQL to be querying this one. You need to first transform it into a tabular format before you can use SQL to query it. So all these questions you have to put into consideration when you are talking about processing data. Then the technique for processing data are actually two. We have the online transaction processing and the online analytical processing. So just as the name sound, for the analytical processing, it's more of carrying out analysis. For instance, you calculate the books with best profit margin, find most loyal customer, decide employee of the month. This is an example of online analytical processing. Then when you are talking about online transaction processing, like finding the price of a book, updating latest customer transaction, keeping track of employee hours. Like basically you are updating, it's more of like a transaction. You are updating the record, you are creating a new record, you are deleting old record. That's just what that one is for. But when you're talking about online analytical, in this case, you're talking about carrying out mathematical analysis, right, on the data. That's what online analytical processing is. So we have two types: online transaction processing, online analytical processing. Then Yeah, this is also the major difference between them, right? You can look at it from the purpose, you can look at it from design, you can look at it from data, you can look at it from size, you can look at it from queries, users, and so on. You can read this out. This one is very direct, but then I'll just touch one or two. So the OLTP, which is the online transaction processing, support daily transactions. So meaning that every day people must create accounts, people must update their account. For those of you that upload pictures on Facebook, that's an example of transaction. So you are updating your account, you are doing all that. But then when you are now talking about report and analysis of data, that is analytical processing. So you're generating reports, you're analyzing data and using it to generate report. That's analytical processing. We also have design. The transaction processing is application oriented, while the analytical processing is subject oriented. So basically what these two is talking about is that for transaction processing, it's application oriented because application has to make those changes. You have to send those requests to make changes like create an account, delete an account, update an account. They are all through an application. But subject oriented, meaning that you as a data analyst or as a developer, you are now the one, right, carrying out those analysis. So analytical processing is subject oriented. Transaction processing is application oriented. So we'll stop there. Other ones, you read it out, okay? So that we can save time. Except people don't want to go to church tomorrow. So storing data beyond conventional database, we have the traditional database, and then we have data warehouses, and then we have data lakes. And I'm going to briefly help us to take a look at the differences. So the traditional database, like your Oracle, those ones you can just have them on-prem. There's a difference between on-prem and online. That's the one you have on cloud or the one you have on-prem, like database that you have in your office, right in your office there. You can have a database server that you are storing your data. It's an example of this thing. And then you can also have similar server hosted on cloud. They are called traditional databases. It's just to store record, nothing else. So you store the record, you can update the record, you can delete the record. Just using this approach here, which is called data definition language. What this means is that you can create a new record, you can alter an existing record, you can drop the record. Okay, you can drop a user, drop in this case, like delete the user. Then we have data warehouses. Now this is where OLAP comes in. That is analytical processing, right? In this case, I don't know if some of you have heard of BigQuery, if you've heard of Redshift, if you've heard of Athena. In this case, these are data warehouses. You can actually put data there for analysis, nothing else. You just go there to run your SQL query against the data that is stored in the data warehouse. Then we'll have the data lake. This one is a clear example is AWS S3 or Google Cloud Storage. This one, you can store any kind of data there, of maybe structured data, semi-structured data, or unstructured data. You can just dump them there. That's for the data lakes. So, and for this data lake, I think we talked about it during the first bootcamp we had. We talked about it. So we're going to have a quiz before I now go on the revision session, so that we'll call it a day. The first one is okay. Yeah. Follow the installation instruction on the manual. I'm going to send you a manual for to guide you on how you should install. But then we are going to be using this platform. This platform here. So we are going to be using this platform. It's called runsql.com. So we can actually upload our data. I think, yeah, import. We can upload our CSV and then we can run SQL query against the CSV. Then there's another one. Yeah, this one too. This one too is another good one. It's called them SQLite Online, but I think this one we'll majorly be using. Okay, so we can write our SQL query, and then so on and so forth. We can do whatever we want to do. So I'm going to send us a guide, but we are going to be using online platform to run our analysis so that everybody can follow, no headache. So data processing can be basically categorized into two types. Your answer in the chat section, please. Okay, Julie said B. Okay, thank you. Which of the following is not a database type of key? Which of the following is not a database type of key? Primary for independent key, independent key. It's not a database type of key. You put a foreign key. Are you sure you are aware of what you are talking about? Because those two should be there.
We answered the first question. We've not answered the second one.
I thought you have answered the second. You put type B like how
Well,
many times?
no, with the B is for first question.
Okay. So Christy says dependent key. Yeah, there's nothing like dependent key, right? There's nothing like that. But you can have an independent key. What that simply means is that is also referring to a unique key. Unique key are independent key. So basically they are it ensures all values are different and then can allow one empty okay, it ensures all values are different actually. So independent key are unique keys. They are independent on their own. They are very unique. So let's quickly take a look at any question you have so that we can call it a day. Do you have any question? Or you have something you want us to quickly look at? Yeah. Yeah. Yeah, they can be referred to as that. But one thing is that practically primary key, candidate keys, or surrogate key, let me just call it surrogate key. Primary keys and surrogate keys, they can be referred to as what's it called? Independent key. The reason is that they do not depend on any other table to exist, right? Primary keys and surrogate keys, they don't depend on any other table to exist. So you can refer to them as independent keys. Okay. So unique keys as well. Unique keys also falls into that angle because they are very unique and they don't depend on any other table. But then one thing you should not forget is that foreign key are not independent keys. Don't ever forget this one. Foreign keys are not independent key because they depend on another table. So they are dependent key. Please, what's the meaning of varchar? Varchar is variable character. Okay, it is called short. So what this simply means is that you're going to have a word and the word can vary in length. Okay, so you can have it big, it can be small, depending on what sometimes the length can be defined. I think I saw something like that. I've forgotten where I saw something like that. Okay, yeah. On Julie's assignment, I think that's where she made something like that. Let me show you. Yeah, you can see. So here she's defining the length of that of the first name to be 50. So if you are typing your first name now, if you type it and the letter is above 50, it will not be able to register. The database will throw an error. So and the reason why we say virtual, we are now saying that minimum of one letter, maximum of 50 letters. I don't know if it takes null. So minimum of 1, maximum of 50. So that's why they call it virtual. So you can enter anything between 1 and 50. It can vary. So yeah, any other question? If you don't have any other question, then I think we can call it a day. You will get the slide, you will get the recording. I will upload it on YouTube, and then you will also get the instruction for installing it. All right. Thank you, everyone. And yeah, that should be